Hello all and welcome. My name is Charles, and today I'm going to be developing a scalable serverless backend application using Ryax in little time and hopefully with little code. If you're unfamiliar, Ryax is both my current employer and an open source tool capable of doing all of the aforementioned things. And here's the landing page. I'll put the link in the description. The purpose of this video is really going to be getting this use case running in a backend application. So I'm going to be skipping over quite a lot of explanation, for example, what Ryax does and all it's capable of, but all that information can be found on the site, or you can go ahead and look at all the source code or even contribute if you'd like. Source code's hosted on GitLab, but we have a mirror on GitHub. So you can clone this, make pull requests, look at the roadmap, all that stuff. And you can even install Ryax locally and launch it with a Docker Compose up. And then you'll have the UI, which is over here, available on localhost. In my case, I have the privilege of having an instance hosted in the cloud, which I'll be using today. But it'll be the same user interface if you'd like to follow along locally. Okay, let's get straight into it. I started a GitHub page for the backend I'll be creating today, and that exists here. The inspiration for this backend comes from this phenomenon, which you might be familiar with, called WikiRacing. It basically entails going from one Wikipedia page to another in the least amount of time or the least amount of clicks possible. We're kind of more interested in the clicks, like from more of a graph perspective, like kind of related to this concept, like how closely related are all of these nodes in the graph of knowledge that is, in this case, Wikipedia. So big shout out to an implementation of this I've already found, in which you can calculate these degrees of separation and these paths. So let's go from, say, something like Python to onion. And it'll calculate the wiki race. Found 96 paths with 3 degrees of separation from Python to onion in 4 seconds. It's very fast. And then it'll generate this graph, which is really cool. So on this side is Python, and it's going to a bunch of different technologies, and then eventually, I see Venezuela, a bunch of countries, eventually getting to onion. So it'll give you examples of the paths also. So Python, Netherlands, obviously because of Guido, economy of Armenia, and then onion. So that's really cool. This thing I'll also put in the description. And it uses, so let's go back here. This will use, oops, that's the wrong thing. This thing has a GitHub that I'll link also. And it'll use this this gzipped SQL dumps of the English language Wikipedia database, which doesn't seem to be all the way up to date, but is pretty recent and is pretty cool. This is also coded mostly in Python and shell script. Today I'm going to see if we can do it just purely in Python with this tool that I found right here, which is just a Python wrapper for the Wikipedia API. I don't know if it uses any of the same underlying stuff, but basically we're gonna write some code for our backend that'll use this to, and I made a plan, create a data set of wiki articles and their associated links. And maybe in a later video we'll go on to do the actual 6 degrees of separation game and maybe host a front end in Ryax, which we can do as well. We did the introduction. I'm actually gonna just use this instance of Ryax in the cloud, so I have that. Now let's set up some things in Ryax. My data storage for this is going to use an S3 bucket, so bucket storage. And I've already configured my credentials for it in Ryax in my project settings down here. And I'm going to start by getting some useful code imported into Ryax from this open source repository called Default Actions that are basically just a bunch of reusable building blocks that are open source and connect to a bunch of different external providers such as S3, Postgres, all sorts of things like that. So I know I might be going a bit fast, but feel free to slow it down, or perhaps I'll go back through with a slower explanation for all this once it's done. But basically, I'm going to be building all these actions from that repository that have to do with S3. There, S3. I'm going to be making some APIs, so let's get these in there. Let's get this guy in there. Yeah. And I think I have everything I need now. Sleep, that's an action that does nothing. So when we're building these, basically Ryax behind the scenes will be creating a container for each of those bits of code with their individual dependencies so that it can run them individually and scale them, for example, if needed. I think I've got everything I need here. So now in the library, we should see a number of actions, and there are a number of actions building into Ryax right now. Let's go back to my GitHub and add this in there too. Let's get out of this because let's just call it wiki. And so if we try to scan this, we'll get nothing. There we go. But that's where we're going to be pushing our code for the actions that we're going to write. The first thing I can do directly in Ryax, if I've got my actions built, which I do, is just right away make an API. So I'm just going to do that. Wiki, I'm not going to put a ton of info. I'm just going to skip right past that. Path, wiki, scrape. So here we're going to have a workflow that is going to scrape some wiki articles and then save them and their links. And then we'll have another one going in that'll keep triggering the first one so that we continue to accumulate a large data set of Wikipedia information. It's going to be a post, and we'll add one input, which will be like the name of the page, and that's it. Page name. Oops. So query, and this will just be a string. Cool. Yeah, and just like that, we have an API. So we can go here to we can deploy it actually, and we can go in Ryax to our Swagger, which should, oh, maybe I actually need to connect it to something. Okay, let's do something here. Let's sleep. And we'll sleep for 100 seconds. So that'll be our API. We have an endpoint that we'll post to, and then all it'll do is sleep for a while. So that's deployed. And now, there we go. We have this endpoint that we can try out if we want. It won't do anything. It'll just sleep. But we can input the page name here. So that's cool. Already backend in very little time. So let's undeploy this. And basically what it's going to do, it's going to scrape a Wikipedia article, and then in the end, we're just going to upload that file to AWS. So this will be so I already have this stuff set up. Let's see. I think I have this stuff set up. Let's go back in here. I do, yeah. Yeah, this is going to be one of my variables. S3 key. This is hanging a bit on my machine. Let's just refresh. Okay, hopefully now. Yeah, there we go. Secret key, I already have these configured, and my bucket name, and timestamp. No, that'll be like if I wanted to upload a timestamp with my file, and we'll just call this one scrape wiki page. Cool. Okay, that's done. And then we can do another, let's see, we can have another that'll, it'll run on a cron job. So every so often, what we'll do is we'll need to look over the objects in our storage, and we'll need to create a new execution of our scraper using the new links, and we'll like follow the links to get new pages. That's the idea. This is probably very hard to follow, but hopefully it comes together. I do need one more thing here, which will allow me to post, there we go, to the endpoint I've already created. And we'll call this follow links in data. Yeah, good enough. So for now, we'll just say it'll sleep, and then it'll do that post, which is probably still building. Oh, seems like it's built now. There we go. Cool. And we can even fill out some of the inputs for that already. Right. So, all right. I'll need to fill out my inputs here. We have no file to upload for now. Okay, let's skip over that. Let's just try to use this. Let's make the actions that'll deal with this stuff. So, let's see. So I haven't used this thing before. This is my a folder that's linked to that GitHub repo that I showed you. There's the plan. And I'm going to start by setting up a virtual environment. I use Poetry. I like Poetry. It works well. We can use Python 3.10. No. Nice. So now we have a virtual environment, and we can get that going. We'll also need to add the Bodo 3 interface. I think it'll just be Bodo 3, I hope. Yeah, and that'll be for connecting to our S3 in the Python code. So we already have the actions that'll do some S3 management, but I think I'll probably need it in my Python code directly as well, so we'll have that here. And otherwise, let's see, let me think. I think I'm just going to be using standard library stuff. So let's get right into it. I'm going to make, let's make two different folders for two different actions. So I have this actions folder, and let's say create one called pull wiki article, and we'll make another one called search links in data. Okay, and now actually we have this tool over in the default actions, which will be here. And we should have, actually I think it's here. Assets. Let's see what's in there. Yeah, it's that. Okay. So we're going to generate an action template in this one. Poetry add, I think it's called PyYAML. Is that how it's done? I think that's right. So we were missing the YAML dependency. I think that's what it's called. I hope I'm not downloading something I shouldn't be right now. Poetry shell. And then we're going to do that same thing. This guy right here. In pull wiki article. Nice, that worked. And then in search links in data. Nice. Okay. So what that did was in both of these repositories, it generated for us, what do I have open here? Pull wiki article. It generated for us 3 files. These 3 are a requirements file, a handler file, and a metadata file. We're going to go ahead and fill those out, and that'll give Ryax the requisite information to run our code in Ryax. So this one will need Bodo 3, and that's probably it. And our other one will need that Wikipedia API thing, which was actually this. Okay. And the handler, that's basically the interface for both of them. And the metadata looks like that. Okay. All right, let's get started. This one we'll use to do basically this thing. Let's follow this. So this, import that wiki page py and then we should have like, yeah, nice links. Okay, so this here we have the Python programming language page of Wikipedia, and we have all the links, which is a dictionary, like key value, like the name of the pages, and then something else, ID, that we don't care about, I guess. Ooh, we have a summary too. PagePy summary. And what about like PagePy title is just the same thing? Yeah. Nice, cool. Okay, we're just gonna do that. It's simple as that. It exists. PagePy exists. Like that. True. Okay. That's basically all we're gonna do. So let's write some of this code first. So we need to import. We'll use JSON because we're going to be passing around some JSON in our application, and import Wikipedia API. And what this is going to do is, actually, let's write a, yeah, what this is going to do is take a page name that'll come from our inputs that'll be defined right above in our metadata file, and it's going to do what we had before. What was it? Wikipedia API dot Wikipedia, right? Wikipedia with we'll do it in English. Nice. And then the page is the same thing we saw before. Wiki. In this case, I just called it wiki. Page, yeah, of the page name. And then we'll do like if not page dot exists, then there's a problem. Print, we'll say like page with name, page name does not exist. And we can create like a custom exception, raise class wiki page does not exist exception. Right, there we go. That's unnecessary, but just a little more verbose. Boom, we'll raise that exception. And if not, we'll save it. We'll save this page. Or we'll save the summary, and we'll save the links. The links so that we can eventually follow all of the links later. So we'll save it at page.title.json. Yeah, and then we'll do, we'll have to write that information to the JSON, which will just be a JSON object that'll be coming from a dictionary and a location to write that. This will return none. It'll just do with open where write as f JSON dump this to that file. Cool. And then we'll create the object that will dump into there, and that will save to our S3 eventually. We'll have like a summary, which will be page.summary. And we'll have the links, which is a dictionary, so we can just do a, yeah, let's turn it into a list. Page links keys, like that should be fine to get all the names of the keys. I think that works. Yeah. Write JSON of object to dump, and where will be our save location. Nice. And we'll return page info is at our save location. Okay, now we just need to fill out some of this metadata. So the description will be scrape a wiki page by name. Scrape wiki page. There we go. Scrape wiki. We'll just call it like that. And the inputs, we just have one. It's the name of the wiki page. Human name will be page, or page name. The name is what we're calling it in our program underneath, so it'll just be page name, and this is a string. And our outputs, same type of thing. Page info as JSON. Human name is page info. The name is as seen in our program, and the type of this is a file. Nice. Let's just put this information up there. Or like here. ID, inputs, outputs. Okay, that should work. I suppose we could run this locally to check. Then we'll handle page name is input string input input a page name. Okay, let's see if that works. Python actions, pull wiki article, and Ryax handler. Haha. There was a problem. I should just use a linter, but oh, this is in my. This is here. Yeah, I see. Page name. Celery. That seems to have worked. So let's do. We can just print page.summary. Check if that worked. Celery again. Nice. Okay, that's working. Okay, let's work on our other one. So this one is what's this going to do? It's going to connect to S3. We'll import JSON 2. And let's go over to this photo3 doc. Yeah, so this is the thing that I'm going to be using. Yeah, it's this thing. Which I've used before, so I know kind of how the interface works. I'm just going to try to go quickly here. Basically, what we need here are our S3 credentials. So the key, S3 key, let's call it key. And the type of this is a string. Our S3 secret. Secret, and the type is a password. And then we have the bucket name. All this is going to be used to connect to our S3 bucket. And the type is also a string. That's all we need. I mean, what we're going to do basically is we're going to be scraping these articles using the code on the left, putting them in our S3, and then using this action to be taking those and following the links to create kind of like this graph structure that we saw in the example. So it'll output, it'll have to be like a request. So the JSON request for a new page. Page request, page, right, we'll call it that. And the type of this, I guess, is a string also, and we'll have it be a JSON compatible string. Oh, we didn't change any of that yet either. We'll put those there. Description will be follow links from S3 bucket items. Human name is like follow links. And we'll use this to create this graph. So what's this going to do? So the key is going to be our inputs key. The secret is going to be our inputs secret, like that, and the bucket name will be our inputs bucket. Okay, we have our inputs, and now I'm going to write a quick function to connect to that bucket, which is going to take the name, key, and the secret, which in Python is just going to be a string, and it's going to return, I don't know, I'm not going to do the type annotation for that. Photo3 resource. Yeah, this thing, close that. S3. And needs to take AWS access key ID, which is going to be our key, and our AWS secret access key, which is going to be our secret. I think that's how that interface works. I could verify that here. Access key ID, secret access key. I think it's gonna work. Let's hope. S3 dot bucket of our name, bucket name. So this will return our bucket, and here we'll need to recover the bucket. We'll connect to bucket with the bucket name, key, and secret. Nice, now we have our bucket. And first we're gonna go over the objects in the bucket, which will be, I started this because I want it to be a sorted list, so I can just do that. So it'll be a sorted list of object, key for object in bucket. How does that work? Bucket. That's buckets all, but this is a singular bucket that I'm using. I think it's the same type of thing though. Objects all. And here I have a bug. Okay, that should work. And what's this going to do? For each of those objects, it's going to go over it. So each of these objects is going to be one of these things. That's going to be a summary and links that we're going to put in the bucket. So this is going to go over all of those objects. And it's going to download them one by one. We don't want to download them in a heap because we're going to start accumulating a lot of data here, and we don't want to download all of them at once. So we're going to download, this string representation of the object, which should have the file extension in it. Let's hope so. And then let's do a bucket. You can do a download file. It's not giving me the interface here in Vim, but that's fine. Of that object in that download location. Yeah, okay, yeah, because we're just getting the key. I just took the key out here. So now we have that file, and we want to load it. So we need a loader function, load JSON from where, and this will return a dict of our JSON. So with open where read as f will return JSON load f. Simple as that. Let's see. Yeah. So bucket object, or let's say JSON object will be load JSON of that download location. Yeah. Yeah, and then for link name in JSON object, and again here on the left we know we have this parameter or this key links in our object. Let's make sure I'm still recording here. For each link in that, I'm gonna go ahead and close this now because I don't feel like I need that anymore. For link name in links, so we're gonna iterate over our links. What do we do? So we're uploading these by name of the article into our bucket. So if the link is not in I want pathlib. I love pathlib. Path object stem, which will give us just the file name, so the title of the article. So if this link name, which is the title of another article, is not in a list of is not in our objects in the bucket, is not in the file names of our objects in the bucket, that means that we have found something. What's this? So it's not, if it's not in the bucket, then we know, what do we know? And what's my issue here? I wanted a string of this. There we go. Then we know that, let's just print it out. Found new article to fetch with name link name. Cool. And then what we'll do is return, actually we want this here, and we'll return, what did we call it? Page rec will be a call to our first API. So a string of JSON dumps of just something like this. I think we called it page. And we can check that, yeah, right here. Yeah, page is the parameter that we want from our API, and the page is going to be the link name. Nice. And otherwise, so in that case it'll return. I think I have this all lined up. It's a little messy. Let's just do this. That looks right to me. String JSON dumps. It'll be a string anyways. It's fine. Else. So we'll have a for else statement wherein if that doesn't work, we'll print all links have been followed. We hit a dead end. This means that we have, for every page we have in our S3 bucket, we also have all of its links in the bucket, which would be quite surprising if we got to that point. All right, let's push that stuff. Actually, we also have, we can use this guy. So we found a bug. Line 9. Oops. So actually, what was that telling me? It must be in the second action I was creating. So in the search links, where is this? Why is this telling me that? What we can try to do is just run it. There's probably just something very obvious going on that I didn't notice. Unmatched trailing parenthesis. So we can check it by running that other one as well. Rabbit. That worked. So if we have a problem, it's in here, but that's running just fine, which means there shouldn't be a syntax error. Maybe it's somewhere here. We're just going to assume this is all okay and move forward. So we're just going to add everything. Added 2 actions. And we're going to push it to our repository. Okay, now we have my code in here. Nice. And I think I already put this in our library. Yeah, nice. And we're going to scan it, and on GitHub it's main, not master. And here's what we're going to find out. Nice, they both scanned without errors. That means that we can build them. Okay, so while those are building, let's see. We can also do a third one, which will just list our bucket contents, because we do have, I have some music going on outside my window. Very nice. From here, we're going to get one more action that'll just allow us to run one of these workflows once with a manual trigger. Enjoy the music. My apologies, that's probably pretty annoying in the video. But now it looks like both of our actions built. So now we can build them into our backend. In our API here, we want to use this scrape wiki page. Oops, I refreshed too early. There we go. That's going to take the parameter from our API called page, and then is going to come in here and is going to upload that page info, so the links in the summary, to our bucket. Okay, let's deploy that, and then I'm going to make this other action we can just trigger manually. and it'll list the items we have available. So this is our key, this is our secret key, and this is our bucket name. Deploy that. That's deployed. And then we can just start we should have an API running here. Let's just undeploy and make sure we have everything. Wiki scrape. Okay, let's deploy that. That's deployed. Go to OpenAPI. Yeah, there we go. So now we can try out our endpoint. Try it out. Page. Machine learning. And execute. This sometimes takes a second for the first one, but once it executes, it'll give us the information of that API call. And while that runs, we can complete this workflow, which will run on a cron job. And let's just say like every 5 seconds, every 10 seconds it'll run, and it'll do that thing we were talking about. It'll follow the links that are in our bucket. So here's the action that I just coded. And we get the variables, that's the bucket name. And it'll make a post request to the endpoint here. So it's this endpoint. And that one. With the parameters that were output by this here. Oh, you know what? I think that might take... Yeah, I think I have one issue. This needs to take, or needs to output not a string, but a long string, because our request parameters can potentially be a very long string of variables, parameters, whatever it is. Using long string in request. And git push. Boom. We'll have to rebuild this, so let's come over here. We can just rebuild it directly. You can also go in and delete it here. And as long as my code is pushed, which it is, we can scan again on the main branch. There the follow links showed up because I had just deleted it, but we're going to build a new one. Shouldn't take long to build. Let's see. There we go. Built pretty quick. Now we can come back here and finish up our entire backend for the moment and get all of this automated. So we have our key, we have our secret key, and again we have our bucket name. There we go. And the post request will be posted to that other endpoint, and we'll use, there we go, yeah, it takes a long string right here. That request. Before I do this, actually, you know what? Let's just deploy it. Let's just do it. Let's just see if that works as is. So what this should do, and we can go in, so we already, the API, we tried it out. See, so I input with machine learning, I ran this workflow, and you can see that it has a run already. So no logs. This should just be the description of the machine learning page, and then we uploaded that file to our bucket. Nice. And then this one should be running every 10 seconds. It might take a second for the first execution to show up. Yeah, so this one's currently running. It did the follow links thing, and it followed the first link to academic conference. And then it's going to send the post request. Hello all and welcome. My name is Charles, and today I'm going to be developing a scalable serverless backend application using Ryax in little time and hopefully with little code. If you're unfamiliar, Ryax is both my current employer and an open source tool capable of doing all of the aforementioned things. And here's the landing page. I'll put the link in the description. The purpose of this video is really going to be getting this use case running in a backend application. So I'm going to be skipping over quite a lot of explanation, for example, what Ryax does and all it's capable of, but all that information can be found on the site, or you can go ahead and look at all the source code or even contribute if you'd like. Source code's hosted on GitLab, but we have a mirror on GitHub. So you can clone this, make pull requests, look at the roadmap, all that stuff. Well, that's all. Thanks for watching. I'll end things here with a snapshot of our backend in Ryax with a couple workflows that are automating the scraping of Wikipedia and adding all that data to our bucket with the links so that we can later create the graph of Wikipedia links and hopefully get closer to this 6 degrees of separation Wikipedia racing game. Thank you for watching.